I didn't have any dropouts from the first year master's students, but about a quarter, I think, of the undergrads dropped out. And they would come up to me and say, it's too hard, I can't understand it, it's too difficult. And they just drop out, and often halfway through the course. Right? So it was a major trauma for a lot of these guys. So now, the reason I'm saying that is that a similar transition will occur between masters and PhD. See, PhD students, they are again highly filtered. And what kind of people are PhD students? Why do people want to get a PhD? Like in America, for example, maybe I'd say about 1% of the population has PhDs. Right? So they're the elite. They are definitely the alphas. So what kind of person wants to have a DR in front of her name? And what do PhDs do? I mean, in the waging phase of their career, personally, I now see people's lives divided into three major phases of life phases. So there are preppers, people going to school and university, preparing to become wagers, which is the second phase, the waging phase, where you earn a living, you're paid to do something for your work, and then you save up, and with long life expectancies now, then you can go into the third phase, change careers if you want. If you love your job you're doing in phase 2 as a wager, fine. But if you're bored or you want to do something else, you can, because you have your own money now. You can live much more cheaply if you want, if you have the money, depends how much you saved. So then you can ARC, that's ARC, after retirement careering, and I'm an ARCer. That's how I refer to myself. And then you can have a whole other career, and you have 20, 30 more years of life in which to do your chosen career. I mean, chosen in the sense you're totally free to do what you like, so you do what you love, okay? And so your motivation is much higher. The achievement level may be higher because you're more motivated, and you're more motivated because you're doing what you love. Okay, so I'm an ARCer. Anyway, so PhD students, you're finishing a PhD, so you're still then a prepper. Right? You're still in phase 1, although a rather older prepper. And then you get your job and you start being what? Well, if you've got a PhD, typically there'll be one of two things that you'll do, usually. One is just a researcher in some kind of lab. Some people go into finance, that kind of thing. But they're using their superb intelligence, PhD level intelligence, and considerable training. So they're disciplined. If you get a PhD, you're not just bright. It's a high IQ. Being an alpha, the top 1% of intelligence. That's not enough, because there are lots of alphas who are just slobs, useless, not motivated, lazy, don't do anything. So you need other qualities as well. So to get a PhD, you also have to be hardworking. You've got to write a thesis, you have to study lots of stuff, you have to be creative enough to create new knowledge. Like master students on the whole, well, it's no longer true, but it was, more or less got to the frontier of knowledge. Whereas PhD students have to extend the frontier of knowledge, add to knowledge. The fact that I'm doing a PhD 1 and PhD 2 level courses of known knowledge belies that idea. It's a bit old-fashioned nowadays. But anyway, so you're either a researcher or, well, you're a professor. Now, if you're a professor, you're researching, of course, and you're teaching. So the teaching side is very important, because as a teacher, you're transmitting your knowledge. See, as things get harder, students start increasingly getting towards the limits, the intellectual limits of what they're capable of. their brains. So the level of difficulty of the tasks is getting close to the limits of the intelligence limits, if you like, of the students. So learning can be a bit of a hard slog. So one of the tasks of the professor is to break the ice, to point out to students like the essence of some topic, and professors are supposed to be good at that. They're supposed to know the topic well enough that they can go to the heart of the matter and present that, and then not worry so much about the details. That can come later. Whereas if you're not a master of the topic in a sense, then that's harder to do. Then you have to break your own ice, and that's tough. Now some professors are just so smart, they can just look at stuff and say, oh yeah, zip through it. Now, for example, I'm getting a taste lately, very lately. I've been looking at, I'm looking at I'll just show you. It's a 2-volume set, but you can see Quantum Fields and Strings, a course for mathematicians. And this course was spread over a year and organised by the Institute for Advanced Study. Right? That's the IAS. That's the Einstein Institute, as it was called. That's where Gödel was, and if you're a pure mathematician, that's where Hermann Weyl was, another mathematical god. So the IAS, that's the place. It's in Princeton, in America, in New Jersey. It is the home of the super genii. They're the guys over 200, IQs over 200. They are super genii. Anyway, they put on a course on quantum field theory and strings for mathematicians, as the title of these 2-volume books say. And when I look through it, now the people who went as students to these courses are themselves highly selected, so they too are probably probably over 180 IQ. So these are super bright. So the pace at which this material is presented and the level of abstraction is, for me, because I'm just not in that range, right, is daunting, to say the least. It's a challenge. The only way to get through it is a hard slog. So, as getting back to the transition between masters and PhD, the PhD level material is aimed at PhD students, and the percentage of master's students who go on to get a PhD is again, I don't know, maybe 1 in 5, 1 in 10. Again, it's the same sort of order of filtering as occurs between bachelor and masters. So the PhD 1 level courses and 2, they're pretty much the same level. Well, anyway, but you'll notice that if you keep following me for years and you start doing the PhD 1 first year courses, at that level you notice a distinct upgrading from in the level of difficulty, abstraction, speed, just the almost unconscious assumption I'm making with your ability. So I hope some of you will keep following me for years, as long as I keep doing this. Okay, so I only have 2 texts so far at PhD 1 level on theory of computation. As I say, my main focus is math and physics, but these 2 books are very, very mathematical anyway. So okay, here's one. So again by Davis. I really like this guy. He's one of the pioneers in computability. So this one's simply called The Undecidable, and the subtitle is Basic Papers on Undecidable Propositions, Unsolvable Problems and computable functions, and it's edited by Davis. And some of the big names, let's see. Well, yeah, I'll just read out some of the names. So it's a collection of papers, research papers, by very big names. Well, yeah, very big names. Gödel, Church, the same church of ChurchTuringThesis. Turing, and then Rosser, I've not heard of. Okay, and Clean and Post, I've heard of those, right? So, the actual research papers that we'll go through, and that's sort of typical at PhD level. You're reading research papers a lot. So, PhD 1 level, okay, the undecidable. And another one, I've shown you this one before. So on computability, at definitely PhD level of abstraction is at that level. Okay. So I've shown you this before. It's quite with my finger. It's quite a thick text. How many pages? I guess 400 or 500. Ooh, 550. It'll take ages. Right, and very, very mathematical. So if you like math, you can probably see why I've put in some theory of computation courses, because it is so math based and just fascinating. I mean, especially the computability stuff. And now, I mean, there's a whole industry. There's large numbers of researchers working on trying to figure out, trying to look at the set of computer type problems. Well, let's say the set of problems, and dividing them, filtering them into computable and uncomputable. Because if you know a problem cannot be computed, if there's no algorithm to decide it, if you like, what's the point of working on it? Because it's just going to be wasted. Because if it's been proven to be unsolvable, then you can't solve it. So why bother trying to solve it? Okay? So it's useful in that sense. So a lot of people are working on that, and for math type people, for math brains, it's a fascinating topic. All right, I've been rambling on quite a while. I'll stop there. So next chapter, theory, will be chapter 4 on decidability, and I think the highlight of the whole course. Ciao.